Okay students, welcome back to the second video of essay question practice series. Today we will be discussing an electrochemistry question, a model paper question. So yeah, we'll do and see. Seventh question. So electrochemistry is one of the most basics. Basics means that you can easily score. So 7B, first one. Okay. First let's draw the cell review. First let's draw the cell and connect. Okay, is the structure. So we can connect a bulb over here. We can connect a bulb and let's name the solutions. Let's name the structures. This is a zinc rod, this is a platinum. Okay, this is one is a redox electrode. The one on the right side is a redox electrode. 1 0 mole D minus 3. Fe2 plus aqueous, Fe3 plus aqueous. Okay, here we have zinc chloride, 1 mole D minus 3. Okay, this is a salt bridge. This is a salt bridge. Okay. When the two electrodes of the above cell were connected using a copper wire, a current flows. Okay, a current will flow. Write the following relevant to that cell. So we are supposed to write the anodic reaction and cathodic reaction. Okay, students. So let's say now you know the electrochemical series. So from the electrochemical series, zinc will be above Fe2 plus Fe3 plus. Zinc will be above iron. Let's say zinc will be above iron in electrochemical series. Let's write that in zinc will be above iron in the electrochemical series. That means if zinc is above iron in the electrochemical series, the reduction potential, the reduction potential of Fe is higher than zinc, and it is also given, also can be distinguished. Now they have given the, now let's say you don't know that iron is below in the electrochemical series. They have given you the values, Ramai. They have given you that zinc has a negative electrode potential and iron has a positive electrode potential. The higher the electrode potential, now this is the point I want to write. The higher the electrode potential, most the higher the electrode potential, the higher we can say the higher potential of that particular electrode to undergo reduction. If undergo reduction, let's say an electrode has a higher electrode potential, that means he likes to undergo reduction more. That means more favorably it will undergo reduction. Okay. So among zinc and iron, iron will undergo reduction. So we are supposed to now here reduction will take place. I write it in another color pen. Here reduction, here oxidation. Okay, reduction and oxidation. So we are supposed to write the anodic reaction and cathodic reaction. At anode, zinc solid will oxidize to zinc 2 plus aqueous plus 2A. At cathode, Fe3 plus aqueous will reduce to Fe2 plus aqueous. Okay, so the cell reaction will be zinc solid plus 2Fe3 plus aqueous goes to zinc 2 plus aqueous and Fe2 plus 2Fe2 plus 2Fe2 plus aqueous. So the fourth one, standard cell notation. So we can do like this now. First we will write the cell notation. Now this is a review. Okay, I'm writing cell notation of anode will be, now I told you how to write the cell notation. First we will write the conduction tip to, first we write the let's say here in this case zinc to the part or to the species where I attach the external wire. So in this case zinc. So this will be the conduction tip, and then I separate it with a straight line, and at last we should write the solution, Cl minus, but in between there is nothing. So instead of keeping that space, I will just write Cl minus here itself. Cl minus equals 1 mole D minus 3. Okay. Then let's write the cell notation for cathode. Cell notation for cathode. Cell notation for cathode will be zinc, again the conduction tip, that means to the rod where I will attach the external wire, platinum solid. Separate it with a straight line, and then we have the solution. Fe 2 plus equals 1 mole D minus 3. Separate it with a comma. Fe3 plus equals 1 mole D minus 3. Now I told you, now we write the cell notation like this. Conduction tip. Okay, conduction tip. That means to the place where I connect the wire, and then at last I will write the solution, and here in the middle I will write the remaining components of the electrode. So this is how you write, this is the like this is, you should follow this in order to write the cell notation for different electrodes. Now for the whole cell, how do you write? You write like this: anodic notation. Anodic notation, separate it with double line, and then cathodic notation, but reverse. No, I told several times that cathodic notation have to be reversed. Okay, so in this case the answer will be anodic notation, zinc solid, second straight line, zinc chloride, or as you can write, sorry, there's a small mistake. It will be zinc 2 plus. Okay, zinc 2 plus. You can write zinc 2 plus or zinc chloride, but I would prefer writing zinc 2 plus. Zinc 2 plus. Zinc chloride is also correct. Okay, aqueous 1 mole D minus 3. Then separate it with 2 lines. Then the reverse of this one. Okay, the reverse of this one will be Fe3 plus. So Fe2 plus. Okay, students. So cathodic notation reverse means the same thing over here must be flipped to the other side. So we write Fe3 plus equals 1 mole D minus 3, and then comma Fe2 plus equals 1 mole D minus 3. Then one straight line and then platinum solid. Okay, then we will receive marks for this question. Next one, find the electromotive force of the cell. So that is the fifth one. We know E cell is equals to A cathode minus E anode. Now cathode is where reduction take place. Okay, that's how I want you to learn. Cathode is always reducing. Okay, reduction take place always at the cathode. So E cathode minus E anode equals to E cathode is 0.77 V minus 0.76 V. So equals to how much? 0.77.76. 13, 14, 15, 1.53 plus 1.53 volts. 6. Question number 6. Explain how making the following changes to the cell affects the electromotive force of the cell. Okay, increasing the zinc 2 plus concentration. Now, students, now in this type of questions, for example in question number 6, when increasing the zinc 2 plus concentration and how the concentration and all affects, first I want you to write the complete cell reaction. Zinc solid plus 2Fe3 plus aqueous. Instead of writing this one, I want you to write, no, I know this is wrong, but to compare, I want you to, now this is the method, okay, this is the method. I don't want you to write this one in the paper. I don't want you to write this in the paper, but just write this in a rough paper. And zinc 2 plus, wait, plus 2Fe3 2 plus. And now start to, now first write this. first write this, and then from this, sorry, from this uh, start from this consider the changes that happen. No, we can write. Okay, now from this you can decide how the reaction, to which side the reaction will favor according to the Le-Chatelier's principle. Okay, starting with 1. When zinc 2 plus concentration is increased, the backward reaction is favored. You know the principle, okay? Therefore, EMF of the cell will decrease. In second one, adding distilled water to the anodic solution, okay. When distilled water is added, distilled water is added, zinc 2 plus concentration will decrease. Zinc 2 plus concentration will decrease. Therefore, then the forward reaction is favored according to which principle? According to Le Chatelier's principle. So according to Le Chatelier's principle. Then therefore EMF of the cell will increase because the forward reaction is favored. Then the next question number 7. A 2 ampere current was obtained from the above cell. A 2 ampere current was obtained from the above cell during a time period of 40 minutes. Okay. 2 ampere current, time period is 40 minutes. Then 100 cubic centimeter of solution present in the half cell of the cathode was taken and titrated with 0.8 mole D-3 km for solution. Considering the initial concentrations of Fe2 plus and Fe3 plus ions to be 1 mole D-3 each, find the volume of K-4 required. The initial volume of both half cells are 200 cubic centimeter each. Okay, students, now in this type of case, first let's say like this. Let's approach the question like this. Initial concentration of Fe2 plus Fe3 plus solution equals to 1.0 mole D minus 3. Okay, 1.0 mole D minus 3. Now they are asking from us find the volume of K-4 required. Okay, then let's say moles of Fe2 plus, no, before that, now initial concentration of Fe2 plus is 1 mole D minus 3. No. Then for time period of 40 minutes, a current of 2 ampere is taken. Then we should first find the moles of Fe2 plus remaining at the end of 40 minutes. Now in this case, if we consider 100 cubic centimeter, okay, moles of Fe2 plus equals in 100 cubic centimeter solution initially equals to 1 mol dm minus 3 into how much? Volume is 100 into 10 power minus 3 dm3. Okay, equals to 0.10 moles. 0.10 moles. This is the initial moles of Fe2 plus. So I need to know the final moles, no? Final moles. Okay. If we use Q equals to IT, I can find the charge of ions, charge of electrons that flow. Okay, that was flowing. Charge of electrons, charge of electrons is equals to 2 ampere into 40 minutes. So we need it in seconds. We need to convert 40 into 60 seconds. Give us how much number? 6 into 4, 6 into 4, 2400 into 4800 coulombs. 4800 coulombs. Okay. Rama, sorry, there's a small part I couldn't read. Moles of Fe2 plus in 200 CM3 solution initially is 0.20 moles. Okay, 0.20 moles. 200 because they have told the initial volume of both half cells are 200 cubic centimeters. Okay, sorry, I couldn't read it properly. Then charge of electrons is this one. Then we can find moles of electrons. Moles of electrons is 4800 coulomb divided by 96,500 coulomb per mole. What's the value? The answer will be, let's use the calculator. 4800 divided by 96,500, around 0.05. 0.05 moles. Okay, moles of electrons. So Fe2 plus Fe3 plus equals goes to Fe2 plus equals plus electron. Electron is to Fe2 plus is 1:1. Okay, 1:1. Therefore, moles of Fe2 plus reacted. Moles of Fe2 plus reacted. Sorry, moles of Fe2 plus formed. Now here Fe2 plus is formed from Fe3 plus. From Fe3 plus Fe2 plus is formed. Therefore, is equals to 0.05 moles. Therefore, now we can find total Fe2 plus moles at the end of 40 minutes. That means 200 cm3 in 200 cm3, okay, is equals to 0.20 mole plus 0.05 moles is equals to 0.25 mole. 0.25 mole. Therefore, moles, now here we have taken 100 cm3. Okay, from 200 cm3 I have taken 100 cm3 and titrated with KMnO4, concentration 0.8 mole dm minus 3. So volume we don't know. So from 200 moles of Fe2 plus reacted with KMnO4 will be 0.25 moles into 100 no 100 cm3 over 100 cm3 over 200 cm3. That means half of the 0.25 only will. මෙතනින් භාගයක් නේ. half of 0.25 is 0.125 moles, no? 0.125 moles. Then we know the formula. Sorry, you can find the reaction of 8H plus MnO4 minus plus 5Fe2 plus. Okay, you have to form the redox reaction. Mn2 plus 5Fe3 plus 4H2O. So Fe2 plus is to MnO4 minus is 5:1. Therefore, moles of MnO4 minus reacted with Fe2 plus equals to how much? 0.125 moles into 1/5. Okay, 1/5 because the ratio is 5:1. Therefore, if you calculate the moles, how much? 1/5, 0.0255, yeah, 0.025 is equals to 0.025 moles. Concentration equals to moles over volume. Therefore, volume of MnO4 minus is equals to 0.025 moles over 0.8 mole dm minus 3. So equals to, the final answer will be, let's calculate and see, 5 divided by 0.8, 0.03125 dm3. So in cm3 it will be into 1000, 1, 2, 3, 31.25 cm3. So this will be the answer. Okay, Lamai? This will be the answer. So everything done for this question. Okay, thank you.